Of course, we have some key lines of latitude. A lot of these we already know. Equator at 0 degrees, Tropic of Cancer in the northern hemisphere, Capricorn in the southern hemisphere, and of course Arctic Circle in the northern hemisphere, Antarctic Circle in the southern hemisphere. Haven't really seen 66.6 degrees described in a previous video, but on the following slides we'll for sure talk about that number. 23.5, of course, we've seen in a previous video lecture. And each of these key lines of latitude show up over here when we think about the key dates. And so the first day of winter, it's just not some randomly picked, oh, it's going to be, this year it's going to be this December 20th just for the heck of it. It all corresponds to where the subsolar point is. And so the first day of each season is in correspondence to the specific location of the subsolar point. And so when the subsolar point is down at the Tropic of Capricorn, that's what we refer to as the December solstice, or here in the northern hemisphere, we'll think of it as the winter solstice. So December 21st or 22nd. The spring equinox, as the word equinox kind of implies, that's when the subsolar point's at the equator. So we'll think of that as the March equinox or the spring equinox, because for us here in the northern hemisphere. The first day of summer is always going to be that June 20th, 21st date, and that's because the subsolar point is at the Tropic of Cancer, the closest it ever gets to us here in Indiana. On that date. Finally, the fall equinox, just like the spring equinox, is when the subsolar point is at the equator. And so we see the subsolar point at the equator twice, once for the spring equinox and once for the fall equinox. Bartender, can I get an equator? Alright, got myself an equator. Alright, equator, I'm going to rotate you 23.5 degrees. So I'm going to take that 0 degree line and rotate it 23.5 degrees, and guess what? There's our 23.5 degree north and south lines. So of course, Capricorn in the southern hemisphere, Cancer in the northern hemisphere. Alright, equator, now I'm going to rotate you 66.6 degrees. And so that's our next result, and there's our Arctic Circle at the top and Antarctic Circle at the bottom. Finally, I'm going to take the equator, let's take it local, let's keep it local. I want to rotate you 40 degrees. 40 degrees because we are in Indianapolis, located at 40 degrees north. And so there, boom. And so we're going to now see each of these different lines work themselves out on these following videos. We'll begin with our first day of winter, also known as the December solstice. Each of these orange arrows represents incoming solar radiation, with the darkest one being subsolar point. And so here we can see the subsolar point is directly over the Tropic of Capricorn, down in the southern hemisphere. Some things to note. If we look at this, if we look at places in the southern hemisphere, places in the southern hemisphere have more daylight than they do nighttime, whereas places in the northern hemisphere, they have more nighttime than daylight. And we can really see that play out if we look at those key lines. First off, all places south of the Antarctic Circle, down there in the southern part, have 24-hour daylight. You can see that as far as they're entirely in daylight period. Whereas places on the equator, where the red line crosses with the black line crosses with the circle of illumination, you see 12-hour day, 12-hour night. That'll be something you'll see throughout every single day of the year along the equator. Finally, you go up to the Arctic Circle up at the top, and you can see that there they have the endless night. They have 24 hours of darkness. Go to the yellow line where we see Indiana. Indiana, during the December solstice, the first day of winter, is in fact our longest night of the year, or shortest day of the year. And we can see that more of our yellow line is in the shaded half than the daylight half. Now let's move to March 20th, the first day of spring. Like I've said before, the term equinox refers to the fact that the subsolar point is at the equator, so the subsolar point is migrating its way closer to us. It was at the Tropic of Capricorn in our previous December solstice. Now it's at the equator, so it's working way closer to us, and that makes sense because plants start blooming here in Indiana, days get longer and warmer, and another school year starts to end, fortunately. So some things that we can also see here, every single place on Earth. It doesn't matter if you're at the Arctic Circle, it doesn't matter if you're at the Antarctic Circle, it doesn't matter if you're at the equator, it doesn't matter if you're at Indiana, it doesn't matter if you're in Martinsville. You have a 12-hour day and a 12-hour night. Now we'll go to the other solstice, the June 21st solstice, also referred to in Indiana as the summer solstice. On the first day of summer, the sun's subsolar point is located directly over the Tropic of Cancer. At this time, areas in the northern hemisphere experience longer days, but also greater insolation numbers. This is the closest the subsolar point will ever be to us here in Indiana. In the northern hemisphere, also you notice that at the Arctic Circle up at the top, they have a 24-hour day, whereas along the equator, they have, once again, 12-hour day, 12-hour night. But then down at the bottom, you have the Antarctic Circle, which has a 24-hour night period. So some things we note: the subsolar point, this is the closest it'll ever be to us, and thus why we have such warmer temperatures. We're getting all that insolation, but also that long daylight period. Now we move to September 22nd, the first day of fall, when the NFL season begins, another school year begins, subsequently many relationships end. The first day of fall, the subsolar point is back at the equator. Once again, we have in all points on Earth's surface, 12-hour day, 12-hour night on the first day of fall, September equinox. This is, once again, the subsolar point getting further away from us, which explains why trees start to lose their leaves and why you start to get cooler temperatures, is because we're getting less insolation, but also a decreasing day length. Going back and summarizing changing day lengths, and so once again it varies by latitude. However, equator, every single day is 12 hours along the equator, every single day. Whereas the poles, like we've showcased, have 6 months of night followed by 6 months of day. Extreme differences between daylight. Whereas Indy, we've got about 6 hours difference between daylight, between winter and summer. So we might get roughly 15 hours in the summertime, but then down to about 9 hours during the winter time. So we're going to go quickly through the seasons, and we're going to kind of get this illusion that Earth is wobbling. Think of the movement of the subsolar point using this diagram. So the subsolar point migrates from the Tropic of Cancer back down to the Tropic of Capricorn throughout the year. So we can think some things to note here. The equator has 2 times each year that subsolar point crossing over it, whereas the Tropic of Cancer, 23.5 degrees north, only has 1 day each year, the June solstice, and Tropic of Capricorn also has only 1 day each year where the subsolar point is directly overhead. All areas in between the Tropic of Cancer and Capricorn have 2 days. So for instance, 10 degrees north has 2 days each year, whereas 25 degrees north has 0 degrees each year of the subsolar point being directly overhead. And subsequently, 10 degrees south has 2 days each year, whereas 25 degrees south has 0 days each year with the subsolar point directly overhead. August 7th is the halfway point of summer, as the subsolar point is directly overhead on that day, working its way back to the equator. And then we also have February 2nd being the halfway point of winter, which, February 2nd, there's something else that goes on that date related to the seasons, and that's Groundhog Day. So why Groundhog Day? Why did they decide February 7th for the day to bring out this rodent from the ground to see if it sees its shadow? Well, because it's the halfway point. It's the exact halfway point between the December solstice and the March equinox. Another way to conceptualize the migration of the subsolar point, once again thinking about the flashlight example. And so for the summer solstice, this is the closest we'll get here in Indiana with the subsolar point being directly overhead. Because as the seasons go on, both the spring and fall, the subsolar point is further away. And so that angle is even lower to us here in Indiana when the subsolar point is at the equator. And of course, as we've shown beforehand, the subsolar point, when it's on the other side of the equator, is about as far away as the subsolar point can get from us, and thus the lowest angle. So whereas the first one, 23.5 degrees north from the subsolar point, would be the highest angle subsolar point we would ever feel here in Indiana, December 21st is the lowest angle as far as that incoming solar radiation or insolation.